Very good afternoon to all. Puttegoda sir, shall we start with the session? Sir, link ಎಲ್ಲ groups ಗೂ share ಮಾಡಿ students. Hello sir, sir start ಮಾಡದ? Okay sir. Okay sir. So very good afternoon all. We'll start with the session. So Jasir sir, shall we start with the session? Sir Nandish sir,
Yeah,
Dr. Nandish sir, shall we start with the session sir?
definitely. Yes. Hello, everyone. This is Dr. Nandish Manangi.
Sir,
I welcome you all.
Before
Can you
we
hear me?
start, we would like to welcome you, sir. Then we'll hand over the session to you, sir.
Sure, sure.
Okay.
Okay.
A very warm good afternoon to everyone. With great privilege and tremendous happiness, I take this opportunity to welcome you all to the technical talk on data science organized by Department of Computer Science and Engineering, ATMA College of Engineering, Mysore, under Computer Society of India Student Branch. Welcome you all. Now, I would like to welcome all the resource person to this event. First, I would like to welcome Mr. Jasir KP, Senior Project Manager, Datamites Private Limited. Welcome you, sir.
Thank you.
Now, I would like to welcome Dr. Nandish Manangi, PhD in Consumer Analytics, Chief Data Scientist and Consultant, Datamites. Welcome you, sir.
Hi. Thank you.
Now, I would like to welcome Mr. Mohammad Minas, Chairman, CSI Mysore Chapter, in his absence to the technical talk. Welcome you, sir. Now I would like to welcome our beloved Principal, Dr. L. Basvaraj, in his absence to this talk. Welcome you, sir. I would like to welcome our beloved HOD, Dr. Puttegoda D, for this technical talk. Welcome you, sir.
Good afternoon to all.
So now I would like to welcome our faculty members of Department of CSE to the talk. Welcome you all. And finally, I would like to welcome all the students of Department of CSE to this event. Welcome you all. Now I request Mr. Anil BH, Assistant Professor, Department of CSE, to brief about our today's resource person.
Okay, good afternoon everyone. Dr. Nandish Manangi has 12 years of experience in market research and client service and business analytics as manager at TCS Bangalore. He has 4 years of teaching experience in marketing analytics and data science domain trainer. He has a certified data scientist from International Association of Business Analytics certification. He has experience in primary and secondary data processing, ensuring compliance with client standards, quality experience, excellence, and process improvements. He has involved in robotic process automation (RPA) for North America client services to drive efficiency across teams. He has Lean Six Sigma Green Belt Quality certified, driving the team to achieve over and beyond client expectations. Currently working as manager in Tata Consultancy Services Limited, Bangalore, and he has worked many academic projects. I welcome you, sir.
Thank you. Thank you so much for that wonderful introduction. Okay. So can I go ahead and
Yes,
start
sir.
this
Over to you,
session?
sir.
Okay. Thank you. A warm good afternoon to everyone. So normally, I take up workshops longer than like 1 day, 2 day, or maybe for a month. But I will do my best to bring you the best of the industry practices in next 45 minutes or so. So how we will divide this session is like um, I will talk about what is data science and what is machine learning and what is happening in the space of AI in the industry and why it is important and what is that so much fuzz about this data science world and why as a student each one of you should know it and try to embrace this new field and which we call it as industry 4.0 and what is that we can gain out of that and also what like how to achieve it or like how data mates can empower each one of you to get a sneak peek into the world of data science. So essentially I will keep these major directions or agenda for today for this session. So without wasting much time, let's understand what is data science. So I will not spend much time on my introduction because I got a very good introduction and I try to stick to it. So just to tell you like how knowledge dissemination happens in data mites is we follow a principle called clips, which essentially means conceptual learning with illustration of solutions to the business problems. So see, normally in academics we look at what data we have and we look at what features we have and what are the tools we can adopt and then come up with some understanding or information and try to then match that with the problems what we have in hand. But in the industry it doesn't happen that way. So normally we keep getting so much of business issues, problems at the organization level, problems at the client level. So normally we start doing it the other way, wherein we will be asked to look at the business issue or a problem, define that problem, and using data science, how fast and how well we can give the solutions for that. So that's what day in day out I spend most of my time in solving business problems for myself, my client, and also at the industry vertical where data science is very much in contention. So that is what we follow in data mites and we follow clips principle. And also along with this, as a supplementary, we look at different experiential learning through video content and also we design refresher activities. So today's session, first session, I will try to segregate as the knowledge part of it. The second part, I will give you some hands-on, at least 2 to 3 use cases, so that you understand what is the wonder, what data science is doing for all of us. And then we also do challenge students or associates with timely quizzes or enhancing quizzes. And also we give them the part of the live business issues for them to solve. So once you like register yourself for data science courses in data mites, you come out with complete confidence on taking up any business problems at given point in time of your knowledge and understanding and also experience on the tools, and you will be able to individually solve it, or you can contribute to the group where bigger problems are looked at and trying to find out how to solve it. Okay, so given that context as a background, let's start. What is data science? See, like data science is a word wherein we will try to bring in three primary concepts. One, the domain knowledge, which one will get as you spend more and more time in the industry. And the domain can be anything. It can be auto sector, it can be a BFSI banking sector, or it can be a core market research like CPG, or even retail, or even anything related to something on the B2B business. So this is how domain will differ, and each one of you, based on your interest, how you want to contribute, you can pick your domain. And the second one is on the statistical knowledge. See, machine learning, artificial intelligence, all these are based on the statistical inference, what PhDs or doctoral scholar bring to the table. In the sense, for example, principal component analysis. Until unless it is statistically proven with the machine learning, then that gets implemented in the AI applications. So it is important as a student, as also a person who wants to make career in this field, to understand the statistics and also the theory around that. And the third one is on the plain coding. And most of the time, the students whom I come across, they do keep tell me that, sir, I'm not from a coding background, nor I've done a computer science engineering. But nothing to worry. Not only for the computer science engineers, but also for other streams. Now I keep telling, it is not a language, it's a English which we sophisticatedly write in a single one or two lines, which fetches us the query, or it acts as a syntax or a queries for which our business issues has to be solved. So that's how we work in data science. And in terms of evolution, how we have done, or how we have evolved in terms of industry 4.0. So now in the news, or even in the social media, you keep hearing about the industrial revolution 4.0. So just to give you a crisp way for all of you, the first we started steam engine, and then electricity came in, then came the advent of computers, and then late in 2000 we started evolving in terms of data also. Like three big data came in, and then convergence happened, wherein different open-ended source were required to handle such big enormous data. So that's how data has evolved. In terms of how this experiential learning in data science is evolved is from 1935, before World War. R.A. Fisher started this experimental analysis. Then came the World War II, during Japanese Deming quality practices started. And then Peter Lund started a business intelligence. And they started with IBM, and then it started with Oracle, and then Microsoft and Apple took it further. The inflection point came in 1998, wherein Google started the complete search engine. So that's when machine learning or machine algorithms become much more evident. And then the fourth industry revolution in terms of data knowledge happened in around 2020. So now we come across different set of data where some are structured, some are unstructured, and some are both mixed in terms of the data is available at different formats, at different level, and also at different velocity. So that's how we start looking at the evolution, and these are the books and people or authors to look after. But three important people in the late 1990s and in 2000 around the newest century, three people have to be considered in the field of data science. One is John McCarthy, whom we call him as father of artificial intelligence. He works at Stanford University. And the second one is on Geoffrey Hinton. He is considered as a godfather of deep learning. He has divided his time. In some part of his time he dedicates to Google, and spend most of his time in Canada, Toronto. And Jan LeCun, he is a chief artificial intelligence at Facebook. These three people have contributed so much. In fact, I would request all of you to follow them in whatever information you get it in terms of understanding. Now, coming to the contemporary world, wherein how data is consumed and also how data is processed or produced. So if you talk about in 2013, the data was in GBs. In fact, production as well as consumption both were happening in GBs. But now, as we have moved away from waterfall model, so many of you are computer science engineers, you guys understand what is SDLC, software development lifecycle. So that has moved from documentation at every step in waterfall model to agile methodology. So agile scrum masters are much more in demand, and their job is to make sure that the resources and efforts are not spent in documentation, but agile in a sprint way, the projects are carried out. Hence, the pace at which softwares are delivered or software as a service is happening is at very fast pace. Next is on the weblogs and social media, how it is emerged. And now M2M, machine to machine marketing, sensor data and geolocations, GPS like Google, GPS, all that. In 2020, we talk about 1 zettabyte, wherein we are producing at the same time consuming 1 trillion of data. So what does it mean is we have to have that sophisticated tools to handle this much data. At the same time, we are not looking at tools to just process the data, but we have to make a meaningful insight out of the data. That is the need. And it is not that, okay, I have information and I will go to different companies and start selling it. No, it doesn't happen that way. Information and data becomes important or critical when it is solving some problem. So that's where now we have a potential to pick up a problems where before the advent of big data, we were not looking as a solvable solutions or solvable problems. So that's what we are doing. So essentially in companies, the industry best practices are there will be different types of data which we will process through different tools and techniques. Tools will be different applications what we use, and it can be a proprietary tools or it can be open source tools available in the market. But using tools or what tools we use doesn't make that of a difference. But what makes a difference is when I'm proving something on a hypothesis, whether my sales are happening only because of, let's say, due to corona or even due to the slagging weather which is around different parts of the country, is that when we want to prove it, the technique uh, becomes a critical part. And using any technique, it can be a technique like statistical methods or modeling or even any data crunching methodology used in different algorithms, you can use it as long as you are able to solve the business issue or give a reason out on the business issue what you are working. So that's how using tools and techniques, when you turn a data into a meaningful business insights, that's where business analytics comes into picture. And many people like get confused, what is data science and what is business analytics? Data science is a bigger umbrella wherein business analytics talks about solving the business queries or question. For example, people at the board level, when I say board level, who are handling at least brand managers and above, they look at different data which can come in the form of management information system or through their customers as a feedback. But the important point is what is that data is saying, that we pick up, process it, and make sure that we make a meaning out of it. And that meaning can be something actionable for the brand managers and above to take action, whether in terms of changing the prices, whether in terms of changing the distribution of the product, or even some of the marketing practices like changing the packaging or introducing a new advertisement related to the product quality. So all that decisions can be made only when we make a meaning out of the data. So that's what business analytics talk about, which is very much into B2B. Now, how we go about planning the work is very simple. As I said, in the industry, we don't look at data first. We look at a problem first. So first, the important critical part, or most of the time we spend is on defining the problem. As precise and concise the problem is, even the solutions and the outcome will be as good. So that's what we believe in the industry. So we spend most of the time in defining the problem. What is the like, for example, the sales of batteries happen too much in March. Okay, so it can be as simple as this, or it can be as complicated as how should be the vaccines of corona can be handled or distributed given the sentiment of the citizens. So it can vary at different levels. So it depends on how clearly you define your problem. And then comes what is the tools and techniques required for it, what is the human resource required, and what is the expertise level, and how long the efforts have to be involved. So that comes in agile methodology in terms of planning the sprints. And once that is done, you build your business case, and then the step of presenting step by step sprints get into the picture. So now here I have written something called SCQA here in this. So SCQA stands for situation, complication, question and answers. So this is mostly used in the industry. It's a one slider. I can, due to confidentiality, I cannot share the live examples, but I can create as many as you want on the dummy data or dummy situations what we are going to give once you join the course. So SQA stands for situation, wherein we define the problem. Then complications is what are the hurdles for that. In the sense, we have to be so clear. For example, let's say the battery sales are happening huge in March 2020. So is it the sentiment of the market, or is it the requirement of the batteries happened, or what is that? So that becomes a complication, but that should be something which makes your situation much more clear and it defines it. Then comes the questions which client wants to know. So there are so what, if not, and also quantifications like if we increase the sales by this much, what is the revenue we are going to generate, or how much product sales we are going to do it. All those questions will come and we restrict the questions to be maximum of 1 or 2, and we'll try to give answers in 2 to 3, wherein different options will be given as part of their choices. And we also suggest what is the best answer or solution for your business question. So that entire thing we create in only one slide, and we take not more than 3 minutes to explain that. So if you think, let's say I've spent 6 months in working on some of the business issue, but still you will get only 3 minutes to give the solution or present the solution to the board. So that's how industry works, and there is no what to say, there is no question of wherein you will get second chance, third chance, and all that. No, since we use agile methodology, you have to be thorough in your understanding of entire business issue and how you have gone about solving it. And during that SQA 3-minute session, you will not be given a chance to what tool you used, what methodology you used, how you harness the data. No, all that should happen at the back end, and only the outcome and options what you want to give to the business owner, or we call it as product owners, we have to give it. So that is how industry works. The reason is very simple. The business models have changed. For example, if you take companies or any IT big companies, before let's say 5 years, they wanted to standardize things in the software front, wherein they said that our delivery will be consistent. Hence, they started something called global network delivery model, wherein the consistency and standardization you pick for any company like Infosys, TCS, Cisco, or even for that matter Microsoft, their standard of delivery will be consistent, and they called that as global delivery model. But now, for example, Satya Nadella said that his Microsoft company's vision is mobile first, or information first, or mobile first. TCS said that machine delivery model is their priority on that industry 4.0. Infosys said that we promise what we can deliver, or we will under promise and over deliver. So that's how they kept on changing their business model. But even the business models are getting evolved. The reason is very simple. It is not that a census department in any federal system or in any government agencies are creating the data. So before, if you look at primary data, it was only census division or few companies who are producing the data, or it can be a internal or information like HR information or salary information or even employee appraisal information, which were used as primary data. Or for example, SEBI data, which releases on a quarterly basis for financial institutes, that data became a primary for many people. But now it's very difficult to differentiate between primary and secondary data. We get every data on online, and that too at a rate at which a human cannot imagine. So hence, it becomes very important, since all of us are producing the data. Even the consumption of data has to have a clarity, wherein we can clearly differentiate who is consuming, how much is consuming, and also what is that he's consuming. For example, you take Netflix. They are the pioneers in terms of creating a recommender system using data science. So they know what kind of genres you watch, whether it is action, romantic, or even a horror or web series, or even movies related to a particular star. All that becomes as a recommender system, and that happens at the back end without human intervention. So that is the power of data science, wherein the processing of data is so fast and the velocity of data is churned in such a way that even the outcome becomes very seamless, and that becomes a new normal for any consumer who is consuming the data. So those are the areas where we are working on, and those who want to make a big career, some of the heads up start which is happening is on the computer vision, wherein how visualization is changed, and the second one is on the natural language processing, wherein machine learning is a thing wherein most of the NLPs or even understanding the psychology of a human brain is being done. And also machine learning is used, for example, now if which we teach in data mites, 12 to 15 algorithms if you learn, then most of the business issues you will be easily able to solve it. So that's the power of data science, and also it is very critical in terms of decision making, especially for the domain leaders. And also, as I said, most of my like 30 to 35% of my time goes into RPA. RPA stands for robotic process automation, wherein, for example, if you look at in 1950s, 60s, Henry Ford revolutionized the assembly line for automotive industry. So similarly, RPA, robotic process automation, whether you use Blue Prism or even Anywhere automation or even ClickView, so they are looking at different steps done in business process outsourcing industry, and whatever is machine driven or whatever is processed by machine, that has to be automated and that has to be seamless. When I say seamless, that shouldn't consume the human efforts. That is what me meant as seamless. In the sense, if there is a transition of data from one system to another system or one computer to another computer, the time and effort required for the movement of data has to be seamless. It means, when I say seamless, no human intervention should be there. Second, it should not consume any time. And the third, it should happen at a back end wherein the moment you look at a computer A and you want to have the data in the computer B, it should be seamless and it has to be virtually available at the back end. So that is what the company called Salesforce is doing. They are moving entire our industry and organization data into cloud. And now with advent of Amazon Web Services and, for example, Microsoft Azure, these people are creating such a big data lake where your computers are just becoming a front end of it. You will access the data seamlessly using Citrix and virtually at any place in the world, and you will get the same speed. At the same time, you will be able to do the same statistical analysis without wasting any time. So that is what the generation industry 4.0 is stand for, and also that is what the expectation of the industry. So what is that each one of us should understand, learn from this is, we as an individual should be equipped with the latest tools available in the market, and some are freely available, some you need to give a licensing for subscription. For example, Python or any other ClickView or even Looker for that matter. Python is open source, Looker is from Google, whereas Power BI is from Microsoft. So companies like Microsoft, they use the model of licensing, which you need to subscribe for it. And those are available at different enterprise levels, E1, E2, E3. Normally in the industry, E3 level enterprise subscriptions are done, which is not available for any person for learning purpose. But however, the open source like Python, all other things are available. Even data availability is so simple nowadays. So most of your learning and experience, what is required to take on actual business problems, you can get that ready offline ahead of time before you are put into shop floor in terms of solving the problems. So now you are able to identify between what is artificial intelligence. In a sense, artificial intelligence is again a bigger umbrella, wherein in that we use source code, syntax, or machine learning algorithms to achieve some solutions to the problem. And then comes deep learning. Actually, deep learning started with Google Go, a game introduced in China, wherein AlphaGo is a game in China where using AI algorithms, the Google application was able to solve it completely without human intervention. At the same time, now it can beat any human who is playing against the computer, or it can beat its own algorithms which have been done, let's say a minute back. So it is self-learning, reinforcement learning, which is happening within algorithms, and hence it becomes much more powerful in terms of unlearning and also reinforcing the robots to self-learn and also give that repeatable consistency every time we use that. So that is the difference between AI, machine learning, and deep learning. So in terms of expertise and also the experience which goes, deep learning is something which requires extensive domain knowledge where you know every permutation and combination to solve any problem. Whereas machine learning is at the surface where you require 15 to 12 to 15 algorithms which can take on many of the business issues and solve it. Artificial intelligence is very application in nature, where you talk about different applications, whether it is Ola applications or even it can be anything which Uber uses, where customer interface is higher. So those are the applications which makes more of a business viable solutions, or we call it as minimum business viable solutions, and then we take on implementing that across different industries. And now coming to what is that as a data minds, as a global institute for data science is there to offer. So we at data minds, we teach our students or those who are aspiring to create a mark in terms of the skill set what is required to become a certified data scientist. We teach these many different algorithms. It can be artificial neural network, it can be convolution neural network, decision making tree, image processing, and like that. So this will be a combination of statistical, domain knowledge, and also in terms of what is required in terms of coding. And believe me, coding like sentiment analysis. You might think that okay, elections are won based on different intuition given by the sentiment analysis by different algorithms, but it is not exactly like this. It measures the sentiment, gives what is happening, tweaking of that as per the situation which is available or happening outside the world of data science is what makes the difference. So even support vector machines is one of the algorithms, time series and XGBoost. These are different advanced algorithms which are used in the industry, and we teach them in a very simple way with live data sets as well as on part of the live industry cases, use cases, which will help you to understand not only the coding which is required for running the algorithms, but also the domain experience what is required to solve the problems. So one is on the algorithm parts. The second one is on the statistics. We take every see statistics like till you learn the simple basics out of it, it might look like a big hill. But as soon as you understand in a simple layman way, it is like learning. Say until unless you get into the water, you will have a fear of swimming. And once you are in the water, and once you learn the swimming first time, then it becomes like very easy thing for you. So that is the difference what statistics makes. And we teach from mean median mode to data modeling as well as linear and logistic regression. So this is the level. Even we can go beyond, given my PhD experience and all that, but that is not required at this point in time. Given the nascent stage what industry is, we are still not exploring the high-end modeling what is available in the statistics. But as long as we are able to handle the data modeling structures, then we are good in terms of solving the business issues. Then, of course, Python as a Python 3 language and also the Jupyter notebook using Python 3, we will teach it. And also, there is a lot of drift happening in terms of data visualization. At the same time, we offer Tableau as a data visualization tool, and that is much more simpler to use. So once you are thorough with the algorithms and statistics, and you can play a big role in the industries like retail, automobile, HR analytics, CPG, healthcare, marketing, banking, finance, and insurance, and also business analytics. So these are the most lucrative industries what they are paying higher as a salary for the people with this skill set. So that's what data mites. We take responsibility in terms of enhancing your skill and also empowering in terms of different tools, domain as well as statistical knowledge. Now looking at the landscape, what we have in analytics. So if you look at, these are different businesses which are done. See, normally students in their academics think that okay, they will target different companies and try to fit themselves into it. I would suggest let's take a different approach. I won't call that as a wrong approach, but the approach now has changed. You have to look at different services what a company offers and how you can get your skill set to service the companies or the service the problems of the companies. So that's what I'm here to share my thoughts around analytics landscape. So if you look at right top, which is on analytics and visualization, this is where most of the entrants or people with zero experience are hired and also paid well. So what they expect is with zero experience or 0 to 2 years of experience, given that domain experience is not that much competitive or the competency level required what would not be meeting the client expectation, they want those associates to spend time on visualizations tools like Tableau, MetaMarket, Teradata, SAS, all these. Even Alteryx is also one of the tool from a company called Alteryx. So they are into data blending and all that. So this analytics and visualization is something which you can easily get in and also create some wonderful charts. I will give an example also in this second session. As soon as I move ahead, I will show you now different hands-on wherein how the visualizations have changed. So it is not that we create a bar graph or a pie chart. Those are gone days. Wherein now it's not just area graph. It has to be a dynamic charts wherein it should on a real-time basis change as per data is viewed. In the sense, there is no latency time. For example, people sitting in India, they take 1 week time in processing the data, creating a charts and send it back to US, and they look at the charts and then make the decision. So that lag time is no more. So most of the industries, they work at zero cycle time investment. In the sense, the data processing as well as delivery has to be at seamless, as I said in the in my previous slides. At the same time, the delivery has to be real time. In the sense, we get onto to Google Drive folder wherein a slide will be put and data will be processed at different end. but at least 10 people on one slide will close it in 10 minutes. So that's what we call it as thank God on Friday. So Friday at around afternoon, we get a request wherein entire that week's data is available on Friday afternoon. So the same day we look into the data, make the assumptions as well as the interpretations, come on a single slide, finish it off in 10 minutes and push that delivery into the C-suite level of the management boards in US. So that is the level of precision what is happening in the industry. So that's where most of the analytics and visualization work happens. The next is on the business intelligence. This is mainly looked at data analyst role or business analyst role, wherein lot of analysis is involved. Hence, Oracle, PeopleSoft software or Hyperion or SAP or IBM Cognos, those expertise will definitely help in terms of making a headway in terms of these kind of services. So why I'm talking about this slide is I want each of the students in different colleges who are coming out this year or even those who have come last year, don't just look at companies and try to build a skill set. For example, IBM Watson is there. So if someone thinks that how to gain skill of IBM Watson, so keeping only the service what IBM does will not make sense to anyone in terms of being a resource full person who is looking for or aspiring for a job in data science. So I would say, what are the applications of IBM Watson? Which all companies uses it? For example, take TCS for an example. There is a myth that TCS doesn't have products, but we have at least 10 to 15 products inside data science, and we just don't work on only the proprietary tools what we have at TCS. We look at IBM Watson to Google Looker to Microsoft Azure as well as Amazon Web Services as a service, even though we spend at least 19 to 20% of our daily time on learning, relearning in the data science, and then we look at what are the services what TCS as a company can offer to different companies. So what I say is, don't look at companies. Companies come, go, or the startups will get created. But look at the services and how you as a person can have the skill to service the client. Once you command this in your skill set, then it's just enhancing the services, and then there will be not just one company, there will be more than one companies to offer you as a skill or pay you for the skill or service what you can solve for their companies. So that's how the industry is moving, and it is very competitive also. So in terms of other verticals like vertical apps, whether it is ad media and applications, that is where it is. And especially companies like Fractal or even Procter and Gamble, all these companies also play, for example, Colgate also, which is based out of means headquarters of India is in Mumbai. They also play a different role in terms of data as a service. So there also you can be part of the data science source. And also the below part, most of the applications are the proprietary. For example, you need to learn technically in terms of having a service. For example, you take, for example, infrastructure as a service. Amazon Web Services is there, Microsoft Azure is there, InfoChims is there also, Google BigQuery. And Google BigQuery is now enhanced into Looker also. So those are very important in terms of you enhancing your skill. And also below, the technologies like Hadoop and all that, these are only the file management system, which we call it as FMS. So this is something where, for example, take company like Nielsen, wherein before they used to collect the data in a relational database or IBM mainframes, but now it is completely into cloud, where the entire data is done through NoSQL. So even the structured query languages are not being used in terms of pulling the data. It is NoSQL. It is completely into open source, wherein data lakes are created, and at the same time, different devices are used to access it. Another technology adoption which is happening is based on the data also. Before it was extract transfer language, Natiza and all these were used. Now it is completely into technical, wherein the tools doesn't become important. So hence we go for open source tools like Python, Jupyter or Anaconda prompts, wherein they have the capability to handle huge data at the same time process the data. So that's where it helps in terms of addressing the business. So this is some of the technology adoption. So now let's spend a quick 5 to 10 minutes on Handson. Okay. So what I've done is, so here, the activity what I've shown here is identify any data set from the secondary source, analyze the data. So, for example, I have data sets. So, here I can these are to play with the and acquire some. So, these are the two big players where they open their data for learning purposes, and it's very easy to pick up data from there. So what we will do is you can go and register there in your free time, which I do it like how you open your Facebook, LinkedIn, like that. I would strongly recommend that you also should spend at least 5 to 10 minutes on a daily basis on applications like Kaggle and GitHub. So these are the applications. As I said, GitHub is from Microsoft and Kaggle is from Google. So there you can source the data. For example, let me empty cars empty cars in the sense motor cars data set, which we will try to download. So for example, motor trend car, this is one of the data set which is available. For example, this is the information about the motor car. So you need to understand what are the variables, how database of data set is set up. And then if you see here, the empty cars is available as a common separated variable as a data set in GitHub also, and also it is available in Kaggle also. So let's download that from the GitHub, which I have done it for your references. For example, the same thing. So you can download here. So you will get the entire data set here. And now let's spend some time on analyzing it. So for example, I downloaded it to save time for ourselves. So here is empty cars, the CSV file, which I have converted into Excel. So let's look at what is this data set and what does it talk about. And we as a resource, what is that we can make out of it? Okay, so this is the data set and it's a very small data set. Normally we handle data in zettabytes, wherein it takes at least a normal computer to open quite some time to process and run the data. So here if you look at this, there are records of 32 records of different automobiles, cars or anything like this is across all. There is Volvo, there is Ferrari, and there is also Toyota. Okay, this is across. Okay, there is Merc, so many versions or so many models. Okay, so there are 32 records, and these are different variables what we have. Okay, I'm using a very technical word variable here. Variable in the sense these are different specifications in the automobile industry in this data set given for different cars. Okay, so now let's try to interpret what it is. For example, MPG stands for miles per gallon. How many cylinders are there? What is the displacement capability? What is the horsepower? And also what is the weight of the car? What is the speed, quarter per second? And how many valves are there? Like the piston valves, how much are there? Whether the car is automatic or manual, AM stands for. How many gears are used? And also how many carburetors. So based on this, the data has been given. What else we can interpret? As a layman, we can only do this. Or let's say you use some of the statistical tools and try to find something. But beyond this, can you give any value addition? I would say very less. At the max, what you can say that you can put a pivot or Excel, or let's see. Let's analyze the data. This is one of the feature what we have in Excel. And many of associates or students forget the power of Excel. Excel is one of the basic and most predominantly used analytic tool. Many people think that MS Office is just a tool for making PowerPoint presentations and all that. No. Believe me, if we are not using Excel, at least we use Excel in terms of delivery also. So just what I did, I selected the entire data and just clicked on analyze data. So it gives you the graph car by model, what it is, how it is, and how many rows are there, even carbureted by valves and automatic and manual. So entire your analysis presentation is ready and you didn't spend much time on this. For example, Q6 car model, how is it doing, like that in comparison also. So you have to just click here and your data will be here. It is taking time for me to get that. So this is the power of Excel, which I told you. But now let's understand, and these are ideas or inputs for you to look in. But let's look into what a tool like Python can give us. For example, for you, instead of saving time, I have got into Anaconda prompt and then logged into Jupyter, and then I have logged into okay. Then I have come here, logged into this is the Jupyter notebook where we upload the file, and then I have run the files. For example, so we have used pandas, and believe me, to run this, for example, for running this code, this is just import, and this is import file, and then this is to check what is that we are pulling. Okay, and then I have pulled a dictionary called pip install pandas, and then I have run it. And for example, let's say here I will run this. So this star says that we are running. Here the entire code is only two lines. For example, from pandas profiling, we are doing a profile report, and pandas profiling a report has been done. So this is running. Let's see what significant difference what we can make using Jupyter Notebook and using Python as a code. So we are using pip install pandas profiling as a dictionary what is already available in open source, and you can very well use it in any of your day-to-day operations, and no one is going to question it. It is just a usage of the open source dictionaries what is available, and we are applying that to motor data or motor cars data set here. So I have run this. Let's give it some time before it pops up. So it does take time given the speed of the system or even internet speed, all that. Okay, so let's give this little bit time. Let's get back to our Excel. What is happening here? It's running up. So let me close this data so that we don't disturb the Python code too much. So let's not save this. So I showed you that in the Excel as a layman, we could look at only the different types of charts, how many automatic or how many manual walls are there. Those charts were available, which we could easily create out of using ideas option or analyze option in the Excel. But I want to show what is that else we can do using Python. Okay, I'll run this some time back, maybe because I have not run from the beginning, it is taking so much time. Okay, let me run this. Data head, let me refresh. Yes, it is refreshed. Let me run this. Yes, now I got it. So you saw the report came in. This is the complete report, like what Python or here using Jupyter network, what we were able to achieve is not just analysis or interpretation, but we got the entire report around it. So data set information, there are totally 12 variables in the sense miles per gallon, all that, and number of observations are 32, and there are no missing cells, there are no duplicate rows. Total size of that file is 5.0 KB, and average record score is 160. And there is a warning also. It clearly says that the displacement is highly correlated with cylinders. So we understand that if we want to price the car or evaluate the car performance, then the displacement and cylinder are interlinked, they are correlated. So that important information we were able to get. At the same time, cylinder and displacement is highly correlated. So these are the two things which are highly correlated within that variables. And not only that, so for each variable, for example, automatic versus manual here, what kind of data is this? This is a Boolean data. There are totally two categories around that, and there are no missing values. Like that, for carburetors, what is that? There are 6 distinct counts. For example, there is 1 carburetor, 2 carburetors, like that. Totally 6 carburetor usage cars also. And how many cylinders were there? There are 3 distinct cylinders. It can be 1 cylinder, 2 cylinder, or 4 cylinder engines. So like that, for each of the variable, there is a complete information as well as the graph. And also it gives relation on the correlation, like how automatic manual is correlated with, for example, let's say weight. Okay, so like that entire heat map is given. Missing values, like for example, these correlations are from Pearson. You can find it from Spearman, Kendall's, or these are the most widely used correlation systems in the industry. And since there are no missing values, the entire data is available here, and also the entire sample data is there for you. What you need to do is just download this or report this or download this into a Word document, and then you can use the chart which I created from the Excel, and your analysis on the motor car trend is ready. And then your skill set in terms of giving advice or actionable recommendations comes into picture. So now, is it interesting? With just understanding two lines of codes in the Python, we were able to create so much of value for the client. So now you can pitch into different automobile models or companies or automobile manufacturers and try to start giving value additions for them. What is the correlation, how the industry pursues it, and also the advantage is once you create analysis report around this, you can sell it to multiple automobile companies as a category report. It is not biased towards any company. For example, there were cars of Merck also, there were cars of Toyota also. So we will segment each of the categories into middle segment, high end, premium, or any value cars segment, and start producing the data and analysis and start selling or marketing that for the companies. So this is the value addition what Python can bring it to the table. So hope this example was good. So this is something on the coding part. Let me spend some time, since we have another 7 minutes, let me spend some time on another use cases. So for example, let's say product marketing. I think people who want to pursue further marketing or finance after their engineering, this is one of the use case which I want to show you. So for example here, so you look at this data, which I only have created based on different sources. So data in terms of time, federal funds rate, what is the rate, real GDP of that country, and quarterly GDP changes, the unit sales of product A and product B. Here I have considered Coke Zero. It's data done for Coca-Cola as a CPG client. So we are trying to compare Coke Zero, which is 0 calories pricing, which is sold at $8 as a margin, and the product price is $20. Whereas Coke Classic, it's a regular carbonated drink where margin is 2 and the product price is 6. If you look at this, we are not trying to compete or prepare analysis Coca-Cola against Pepsi. We are creating analysis among two brands or two UPCs within the Coca-Cola client, which is one priced at $20, which has a margin, very high margin of $8. And here I have Classic Coke, which is present for like 70 years now, Coca-Cola Classic, and their margin is 2. The reason is very simple. Since it is a plain carbonated drinks, the additional calories are not removed from this. So this syrup, what is sold, is from very long time, and hence the margin based on the distribution is only $2. So now, for example, Coca-Cola as a company wants to understand, for example, this month, we are in the month of, let's say, last day of December. Today, should I be promoting Coke Zero or Coca-Cola as a classic? Even though the margin and price are different, and both of them are not competing within each other. Coke Zero is a big player in the calories market or a segment within Coca-Cola or carbonated beverages, whereas carbonate drink, Classic Coke is another segment which they spend a lot of money. In fact, they sponsor events also. So now, what I have done is very simple. Based on the data what we have available in terms of fund rate, GDP, and quarter, so I have created the conversion rate in the sense, for example, if I spend, let's say for 1,000, let's say I decide that I will spend $1,000 on Coke Zero, what should be my marketing net profit for this? So what I've done is I've just converted that into a random and the promotion in terms of distribution, and then advertising cost. For example, if I have to advertise Coke Zero, what is the cost? And customer acquisition cost. For example, why this is $1 is, if I acquire one customer for selling this Coke Zero, that is my $1 made as a acquire cost. means that is also divided in terms of what promotion I do. So based on that, entire calculation in terms of for $1,000 what I spend, what is that profit I'm going to make. So that is done. For example, in year, let's say in year January 1st, 1981, this is the old data, but don't be carried away by that. Now if you see here, we have data which is also projected till 2025. So based on the historical data, we have also projected that for 2025. So what I will do is here, going back to the main page here. So I will just create this for entire my historical data as well as for the upcoming years. So this also I will replicate, and this I have done the net profit calculation for entire historical data. For example, we are here in 2020 November 30th. Okay, so that comes under, and it's a quarterly data. Okay, so we are here October. Yeah, here we are in this quarter, RO number 165. So currently, if Coca-Cola wants to decide on which product they have to put promotion, then let me color this so that when I come back, we have clear understanding. So we like management wants to decide where I should put my $1,000 on marketing promotions. So I will extend this decision also. This decision is very simple. Whichever product is giving me high returns as a net profit is my promotion budget. So here you can easily see $7,000 and $6,692. So easily I can advise Coca-Cola company that spend your $1,000 on Coke Zero because that will give you a high returns, or it has given you high returns in 1981. Similarly, you can go through the historical data. Okay, and now coming to our yellow line, which is this, which is currently the quarter 4 of 2020. And now based on our calculation, it easily says that you have to spend time on Coca-Cola Classic, because this is something not an occasional time. November 30th, Thanksgiving is over in US and Diwali is over in the India. And the next big thing is on the New Year or Christmas. So for time being, this week or today, it is better we invest time on Coca-Cola Classic, which is our regular product, and this will get you at least $7,029 to $6,716 against Coke Zero. So marketing decision at the same time I'm having the data to prove. So that is what or the have to give in terms of their decision. So I was able to show two decision use cases. I have few more which I would have shown, but nevertheless, once you register for the courses, we will show you at least 10 to 50 in the Excel, which we do using Python. For example, many of you would have approached which I would have taken uh, to pitch in for the data science. And also, you never know. We also provide job assistance in terms of equipping you, each one of you, for the interview purposes. And we at Datamites have different PhD scholars at the same time, different experts from the industry, where each one of you can be a live interviewer when you go for the job hunt. So that way, our certified data scientist program is designed wherein you not just learn the concepts but also get a hands-on, which I showed very few, a sneak peek. And we have like this at least 100 use cases to show about. And if I go step by step, and definitely it will take the time what we have spent together in last 1 year. So it will be a complete package in terms of your learning as well as internship and also the live projects and your employability in terms of how much ready you are to enter into this highly paid data science world. Okay, so different roles what we have in the industry, which I want to spend some time. For beginners, it will be analyst or research analyst or even business analyst, and then certified data scientist here. And also for technical things, it is big data specialist or data science developers, infrastructure engineers like AWS, Microsoft Azure, and also people with 5 to 6 years of experience. They are called product owners or business persons or domain leaders. And most of the time the researchers is where even further academicians look in using these tools. For example, if I have to say from the academic standpoint, those who are doing the PhD or are in the role of teaching associate professors, then they do use different tools like smart partial least square. So those are like newly or adopted tools in the academics. So SPSS or SAS or even Minitab are little obsolete. So now smart partial least square is some of the tool which also I can personally teach for the academic faculties where I spend most of the time. At the same time, I can groom and also empower the students from the colleges to make sure that they have enough skills what they need in terms of getting employed and also make a career in data science. So like this, with this, I want to close the session. If you have any questions, feel free to ask me, or also you may connect me on the LinkedIn, Nandish Manangi, NANDISH and I will be happy to address your questions or queries even after this session. So our relationship or association should begin from here and will continue to evolve in the data science world. And I will do my best in terms of imparting or disseminating the knowledge. At the same time, I hope have generated interest and also to certain extent business acumen what is required to for you to start stepping into the world of data science. Thank you. Any questions? Anyone wants to ask? I took 5 more minutes, but it was inevitable. Hope it was a useful session.
Thank you, sir. Thank you so much, sir. So we'll be collecting the queries from students and later on we'll communicate with you, sir, regarding the
Sure.
queries. Now I
Okay.
request our HOD, Dr. Putekodadi, to render the vote of thanks. Over to you, sir.
Thank you, Sneha. It's a very good evening to all. It's my pleasure to propose the vote of thanks to the today's technical talk. So for the kind information viewers or the participant, so ATME College of Engineering started in the year 2010. So just finished 10 years now. So are in the decennial celebration. As part of decennial celebration, we are organized this technical talk on data science with the Association of CSI Student Branch. First and foremost, I'll thank the today's resource person, Dr. Nandish Manangi, data scientist and consultant. So thank you for very much, sir, for accepting our invitation and give the insight view of the data science to the participant as well as our students. Thank you very much.
My pleasure. Thank you for inviting me.
I would like to thank Mr. Jai sir, Senior Manager, Data Mites, giving an opportunity to associate with the ATME to deliver the technical talk like this, and also in future we'll have an association. Thank you very much, Jason.
Thank you, sir. Thank you, sir.
So I'll take the opportunity to thank our management for continuous support and encouragement in organizing these type of events. Thank you. So I would like to thank our principal, beloved principal, Dr. L. Basuraj, for his constant support and encouragement. Thank you very much, sir. So I would like to thank Mr. Mahmoud Minas, sir, Chairman, CSI Mysore Chapter. Thank you very much, sir, for your kind support. So I would like to thank the faculty coordinators, Sneha NP and Anil Kumar BH, for taking this initiation and organizing this technical talk. Thank you very much.
Thank you, sir.
Thank our faculties, teaching and non-teaching faculties for their support. Finally, I thank all the participants. So participate in these type of events, gain the knowledge and apply this knowledge wherever you are applicable. Thank you very much, participants. So I'll continue. Okay, I'll seek continuous support from the participants as well as the organizers, so that we can organize these type of events in future. Thank you very much.
So I want to add one point. This is Jasir from DataMind. So thank you, ATM College, for giving this wonderful opportunity to collaborate with this event, as well as we are conducting a boot camp. This is exclusively for college students, especially engineering graduates. So they are actually really worried about their career. So they are confused what they have to do after the graduation. So this boot camp is such a way that this is actually a one-day session where 3 hours of session in hours we'll give it to students, where we'll talk about data science and AI. This is actually 3 hours of training where experts will come and take the session. They can gain the data science and AI foundation knowledge. There will be some project and live cases also included. They'll get a certificate for this particular boot camp, and there is a toolkit also included worth of 15,000 rupees. In recently, there are a lot of college students attended the session because they have a lot of questions regarding am I eligible for this data science and AI, because I don't have coding experience, I'm not good in mathematics. So all of these questions can be answered in this particular session. So this is actually very cost is involved in this. We charge a very minimal amount for this. 295 rupees is for this particular session. That is included taxes. Why? Because we want to attend a lot of college students, because this is actually a part of our CSR activity. We want to empower the students in all the colleges in India. So last week we delivered a session in NIT Calicut as well as in NIT Pondicherry. So a lot of students joined for this boot camp. From ATME college students also, if they are interested, they can join for this boot camp. We have a boot camp coming on December 5th. It's on Saturday, 3 p.m. to 6 p.m. So I'll share the details with a concerned person. They can circulate with all the students. Thank you.
Sure.
I take this opportunity to thank our HOD, Dr. Putegoda D, for his constant support and guidance in organizing this technical talk. Thank you, sir. So we have come to the end of the session. So we'll end our session. Signing off by event coordinators, Sneha NP and Anil Kumar PH. Thank you all.
Thank you. Thank you all.
Thank you, everyone. It was pleasure, and also hope it was very informative. Thank you so much.
Thank you,
and
sir.
see you
Thank you
all
so
in
much.
the boot camp.
Sure, sir.
Thank you, sir.
Thank you, everyone. Have a nice day. Bye.
Thank you, sir.